Good afternoon, everybody. Thank you for coming and joining us this Wednesday afternoon. Hope you guys have had a good re:Invent so far. Now, for your 1000th poll at re:Invent, before we get started, raise your hands if you've ever been caught in a situation where you had to make a decision and you wish you had some data available to help you make that decision. Raise your hands. Come on. Okay, great. I see lots of hands raised. It seems like a good majority of us probably are feeling what I feel. A lot of times when we get asked a hard question, in fact, right before re:Invent, we were down to the wire on some of our launches, and we had to make some really risky trade-off decisions, and I sure wish I had some data to help make us make that decision. But you know what? I think a lot of times we all get caught in a situation where you kind of have to trust your gut. Go with your instincts, right? Or honestly, just wing it. But that's not to say that that's how we want to operate. I think at the core of it, we all want to make data-driven decisions, right? And there's definitely a lot of data out there, but when you need it to make a decision or when someone's asking a really tough question, you either don't have the right data, or even worse, the data's there, you just don't know how to access it, you don't have the right permissions, or maybe you don't have a good tool to help you visualize that data. And that's really what today's session is about. I'm Helen Lin. I lead product here at AWS for our open source observability services. Very mouthful. And I'm joined on stage with our customers from FINRA, Sumolata Bachu, Senior Director of Technology, and Logan Kodlachik, lots of love, our senior data analyst at FINRA. And we're really excited that you guys are here today because we want to talk to you guys about gathering the right data, having a good tool to visualize that data can give you visibility into your operational and business functions. How allowing data access can empower individuals of all levels of ownership to be making data-driven decisions, the tools that are available on AWS to help you enable this, and then we'll invite FINRA on stage to talk to us about how they leverage Amazon Managed Grafana, Amazon Managed Service for Prometheus to build out their data democracy and observability practices. And then Logan has some really cool demos to show all of this in practice. Okay, so let's get into it. I won't ask another poll, but hopefully if you're in this room, you guys have all heard the word observability before. What does it really mean, though? I think at the core of it, observability really is about leveraging the three foundational pillars of operational data. These are your metrics, your logs, and your traces to give you visibility into how your applications and infrastructures are performing, alerting you when SLAs are breached, and giving you the tools to isolate and remediate issues when they happen. But observability doesn't just stop there. It's not just about troubleshooting issues reactively. It's also about giving you real-time visibility into your infrastructure, your application layer, maybe your networking layer, so that when you make those code deployments or infrastructure changes out into production, that you have that real-time visibility to monitor those changes in real time, course correct them, and ultimately enable your teams to build more resilient apps. But resiliency, whether that means preventing old issues from reoccurring or having operational visibility to minimize downtime, all of this has a direct impact on your end customers' experiences, right? Just think about all of you guys here in this room for a minute. I think we've all been a customer here before. And especially in the last couple of years with the global health crisis, I think we've all depended a lot more on online shopping. Now, just think back to when you were purchasing those pesky TP rolls that kept disappearing, right? When you go to a website, you expect that they have real-time, updated inventory, that there's sub-second web, dynamic web UI interactions, and that real-time interactivity was critical to your purchasing journey, right? Let's face it, there's 1,000 vendors out there. If you have a bad experience with one company, you've already moved on to the next application to finish your purchases, right? And so all that is to say that experience matters, and having a resilient application that can react and recover quickly is important to ensuring that your customers stay happy on your platform. And so observability doesn't just mean that it has an impact on your day-to-day operations. It also has a direct impact on achieving your company and your business outcomes. Now, like observability, I think data democracy isn't a new concept either. It's this idea of sharing data and tooling across your organization to allow your teams to make data-driven decisions. With observability and data democracy, I think the first step really is just let's gather the right data, right? So whether you're gathering data across your application stack, across your organizational metrics, across your business tooling, reality is that you probably end up storing a lot of data in a lot of different formats, and they're being stored in these siloed data islands, right? A common number I've heard from our customers somewhere in the range of maybe 5 to 7, sometimes even more tooling, but they're having to context switch across all these disconnected, disjointed tools. Security and data governance are also critical pieces of the puzzle here, right? You need to be able to collect, store, and visualize your data securely. That probably means that you need to be able to define network access policies, ensure that your data is encrypted at rest and in transit, and ensure that only the right people have access to the data sets that are relevant to them, right? Just because you're building a data democracy and observability platform doesn't mean that you collect the data and just open access to everybody, right? In addition to data privacy and security concerns, not everybody may even know what those different data sets mean, so they may actually end up mishandling or misinterpreting that data. I think scalability really goes without saying. If any of you guys here are sort of running containers, you probably know that you're collecting millions of metrics. A lot of times you're ingesting those millions of metrics per minute. Or maybe you're collecting data on business tooling that's impacting your employee health, that's generating terabytes of logs, right? And there goes my slide. Your data continues to grow, especially as your business scales. So building on services that allows you to expand and grow with your business is important for you to future-proof the platforms that you build, right? So that you don't have scale dictate the observability and data democracy platforms that your teams build. And because I've already given you a preview on this slide, I think a beautiful dashboard is really worth a million words, right? Just compare that last picture to this picture, right? A raw data dump really isn't all that useful. You can collect all the data that you want, but if you don't have a good visualization tool, it's actually hard to understand what's going on in your application or spot those anomalies in your organizational health. Okay, so how can you combine these two practices on AWS? What if you could build a single data visualization tool that allows you to democratize both your operational and your business data across your organizations, regardless of whether your users are IT operators, developers, marketing folks, maybe product like me, finance, et cetera, right? Grafana is a popular open source data visualization tool that allows you to query a wide breadth of different data types, whether these are business or operational metrics, logs, or traces. And the beauty of Grafana is that you can query the data regardless of whether it's stored. So that means you can build your operational data lake on Amazon Managed Service for Prometheus, which is a fully managed Prometheus service that allows you, that auto scales to the millions of container or operational metrics that you may be collecting. You can build your business data lakes on AWS Lake Formation or S3 or Athena. And then you can leverage Amazon Managed Grafana to centralize all of your data querying, your reporting, and your dashboarding needs. And so with Grafana, that means that you don't need to context switch between all these different tools anymore, right? You can now have a single interface and build a view across your infrastructure, your application, your business, and your operational health. Okay, so we launched Amazon Grafana right around re:Invent of 2020. And so just to give you a little bit of intro on what Amazon Managed Grafana is. It's a fully managed Grafana service that allows you to sort of create on-demand Grafana workspaces so that you can query not just data from your AWS services, you can also query data that maybe you have still running in your legacy data centers or on-prem or in your VPC. So maybe you've got a MySQL server or InfluxDB or Graphite. In addition, you can also combine it with data from third-party ISVs. So maybe you want to pull in some CI/CD data from GitHub or Jira or ServiceNow. You can do all of that with Amazon Managed Grafana. And Managed Grafana really sort of takes care of that interfaced heavy lifting, most favorite AWS phrase, right? Where you don't have to manage the scale up and scale down of your Grafana servers. You don't have to deal with high availability. You don't have to deal with versioning and security patching. We sort of take care of all that for you. And if you think back to some of the challenges that I mentioned earlier with data democracy and observability, Amazon Managed Grafana really removes a lot of that friction for you, right? So you can now converge your data islands and have a single place to query both your operational and business data. Data governance was another thing I talked about earlier, where the beauty of Managed Grafana is that you can create a self-service data portal to enable your teams to make data-driven decisions. But it doesn't just stop there. Managed Grafana also supports fine-grained access control, so you can sort of mix and match users with different data sources, different data types, with various degrees of access, right? So that means that opening up data access doesn't mean that you need to compromise on your data governance and data privacy standards. And since we launched Amazon Managed Grafana and Amazon Managed Service for Prometheus back at re:Invent 2020, we've continued to listen to our customers, hopefully many of you guys in this room here today, to continue to innovate around our core pillars. So I'm really excited to share a couple of new things that we recently just launched, actually some of this stuff just last week. So the first thing is we continue to innovate around security and compliance. So Amazon Managed Service for Prometheus is now ISO and SOC compliant. Managed Grafana, just last week, we announced the ability to connect your Grafana workspaces to your VPCs. So this means that you can query, again, not just data from your AWS services or from maybe third-party ICVs, you can connect it to data that's in your VPC or maybe still sitting on-prem securely without traversing the public network. Scale, we mentioned earlier, so with Amazon Managed Service for Prometheus, super excited to now support up to 200 million active time series per workspace. And with Managed Grafana, also 10,000 users in a single workspace. Going back to this idea of having a single pane of glass, sort of consolidating all of your data core in a single place, you can now view your Prometheus Alert Manager rules directly in your Grafana workspace. So this means that if you've created alerts, maybe in a different tool, like maybe Prometheus Alert Manager, you can visualize, manage, and silence those alerts directly in your Grafana workspace alongside your metrics, logs, and traces in a single dashboard. And last but not least, we also released some new visualization panels, Sankey, Plotly, and Scatterplot, to give you even more visualization options to tell your data story. Okay, so by now you guys are saying this is great theory, I've heard enough, I want to see some real-life practice of what this actually means. So I'm really excited to welcome Sumulata Bachu on stage to tell us about how FINRA built out their data democracy and observability practices.
Thank you, Helen. Good afternoon and welcome, everyone. We are very happy to be here today with you all in this breakout session. In today's presentation, we are very excited to share how at FINRA we used Amazon Managed Grafana along with other AWS services to democratize the data and to visualize operational data for observability. Whether you are a senior leadership looking to take data-driven decisions at your organization, or you're an architect or an engineer looking to build a reporting pipeline, or you're someone who just heard about data democratization and observability, you wanted to learn some real-life examples, you're all in the right place. We hope to give you all something interesting today and key takeaways so you can compare, correlate, and apply at later point of time at your organization appropriately. I'm Sumulata Bachu, Senior Director at FINRA, leading data operations. Now let's look at who FINRA is and what do we do at FINRA. FINRA is the financial industry regulatory authority. Our mission is to protect investors by making sure markets operate fairly and honestly. We regulate and monitor brokerage industry and the stock markets in the US. We discipline those who break the rules, and we deter any misconduct by enforcing rules. Sounds scary, but we do this to protect investors. Let's look at a little bit more about FINRA. For the second consecutive year, FINRA has been named as the top one as the best place to work in IT among mid-sized companies. Let's look at a little bit numbers. We collect massive amounts of data from various exchanges and firms who do security trading on a day-to-day basis to look for fraud, abuse, insider trading, and market manipulation. We process about 630,000 broker-dealers' data. At FINRA, we regulate 3,400 security firms. 99% of it is US equities markets data and large amounts of options data. Let's look at FINRA's big data ecosystem. And when I say big data, it's really, really big data. At FINRA, we process peak volumes of 600 billion transactions per day. We work with 24 different exchanges. In order to surveil these market events, once we collect the data, we spin up 300,000 compute edges and nodes per day. Our storage footprint is 500 petabytes of storage. You all heard it right. It's 500 petabytes of storage. We have about 288 different applications in the cloud using various different AWS components that we use on a day-to-day basis to perform regulatory functions. Now, enough about stats. Let's go into our actual presentation. Today, I'm going to cover two use cases. The first one is data democratization for consolidated remote workspace. The second one is how we obtained observability for EKS workloads at FINRA. For both use cases, I'm going to go over our challenges, our problems, our journey, our solution, and the benefits that we achieved from that. After each use case, I have Logan from FINRA, who is a senior data analyst, who is going to do a cool demo and drill down of the metrics. Without further ado, let's dive in. Before we go into the actual use case, I really want to touch upon what does data democratization mean? I know Helen touched upon it a little bit, but I just want to give a quick summary and what does that mean. We all know data is key for business decisions. Data gets created, collected, stored, and disseminated across various systems in various different departments and provided to users based on their role-specific tasks. However, lacks the benefit or advantage of looking at a holistic view, connecting all the data sets in one place. Data democratization has several components to that. The first one is data literacy. What does that mean? It means who are the beneficiaries of the data, who has ability to skill set to read, interpret, and understand the data. Self-service analytics basically is a business intelligence where users have the data in hand to run analytics with the data that they have in hand with minimal technology staff help. Data visualization, as Helen was mentioning, and to me as well, I see more, I can connect more into it than hearing it. Data visualization is how the data gets rendered to the user on the dashboard. Is it consumable? Is it downloadable? And useful for reporting purposes? Fourth component is data governance, where it is setting internal policies and procedures. What type of data is being retrieved, how the data is stored, does it have PCI, RCI, or any sensitive information, and setting compliance and tracking procedures. Last but not least, data security, which is very important, making sure how the data is securely stored with no data loss or data destruction. Finally, quick summary, data democratization is the practice of making data available all in one place, giving it to the users so they can make data-driven decisions securely by considering all these factors. Now that you know what is data democratization means, let's dive into our first use case, data democratization for consolidated remote workspace tools. I want to take a pause here and say that this is very different use case than typical market data or typical any other operational data. With pandemic and remote workspace becoming a new norm, I'm sure this use case will be interesting to all of you, if not most of you. FINRA technology team supports wide variety of COTS products, custom, inbuilt applications that are used by the rest of the organization for collaboration, productivity, and day-to-day activities. All these tools are audio, video, channeling, messaging, file sharing platform tools. But each tool has its own way to measure a metric. Each tool has its own way that a metric is defined. How do we come to a central point to look at all the data so we can make some data-driven decisions? One of the challenges we have with this is having usage metrics for these remote workspace tools. Is a particular tool underutilized, or is a particular tool overutilized? Having that visibility was lacking. Data-driven decisions are nothing but information-led transformations, and we couldn't make those data-driven decisions as we were lacking the tools usage perspective. So proper refinements or improvements can be made for those tools. The third aspect is collaboration. Collaboration is key to success. Believe it or not, collaboration takes a long way to go for productivity. But measuring that collaboration was a challenge. How does technology team collaborate with business team? Is team A always in the bubble of team A, or is team A collaborating with team B or team C? Measuring that collaboration was a challenge. Customer experience metrics, we all want to make our customer happy. How do we measure that? What type of application metrics we measure to derive customer satisfaction metrics? What type of customer experience metrics can we measure so we can make improvements or year after year after year? Finally, having one executive dashboard for leadership so they can come, look at all the data in hand, make data-driven decisions, and think about planning for financial best investment strategies for these tools. So we overcome this challenge, and our solution that we built is using AWS S3 Data Lake along with Amazon Managed Grafana. AWS Data Lake is a central repository of collecting all the data in one place from various different data sources, raw data, structured or unstructured, from different data sources all in one place, and having analytics on top of that data. That data is fed to Managed Grafana. Managed Grafana is the rich dashboarding tool that we used to create the dashboards for this use case. AWS takes care of it in the backend, scaling, provisioning, infrastructure, and patching. Now let's look at our technical solution of our use case, how we built. I don't want to name all the services here, but we built complete solution using serverless. To name a few, Lambda, Glue ETL, Glue Crawler, Athena, Lake Formation. The left side portion of the diagram, what you're seeing, is the architecture for the data collection, and the right side is of the Grafana. The process starts with the data extraction, where we make an API call and retrieve the data of all these remote workspace tools. Once the data is collected, extracted, we have an ingestion process which runs at a regular interval, puts that in raw S3 bucket. Once the data is there, we use data transformation process where it reads the metadata, partitions the metadata, and then registers the data into the finished S3 bucket. Now the data is available for users for ad hoc querying using Athena. The same data can be fed to Managed Grafana. We create Managed Grafana workspace based on certain configurations that we have, and then we are able to build the dashboards. Grafana is SAML integrated, so we integrated with FINRA's Active Directory for users' roles and privileges. Managed Grafana has a nice feature about templatized dashboards. We love this feature, application teams like it, and Logan is going to demo that very shortly. What this feature does is we create the dashboards in one environment, development environment, and after testing, we use our automation to promote through QA and production using CI/CD pipeline process. Each dashboard, what we have, 50, 40, 60 panels. And just imagine creating all these panels manually and promoting to each environment is tedious and time-consuming. Thanks to Grafana has this feature, we use it wisely. Managed Grafana also has a fine-grained persona-based user access where we can have different type of user access for data scientists, different type for operators, or different type for senior leadership. The beauty of this architecture is we set up once. Now, any new data source can be easily onboarded and integrated with the system. Quick summary. We collected all the data from the remote workspace tools, and then we put all the data into the data lake. After extraction, ingestion, and transformation, we fed that to Managed Grafana to create dashboards. We created different tools, usage metrics, customer experience metrics, customer satisfaction metrics, application metrics, and finally, what we have been alluding to, executive leadership dashboard for senior leadership to come and take data-driven decisions. These gave us critical insights and helped us to improve our customer experience. I know I've been talking, but you guys all want to see the dashboards in live, so I'm going to pass on to Logan to see the actual demo.
Thank you, Sumalata, and good afternoon, everyone. My name is Logan Kudlachik, and I'm a senior data analyst in technology at FINRA. Today, I'm excited to be sharing with you two demos, the first of which will be our consolidated remote work reporting dashboards that we built to democratize insights and data around consolidated remote work tools and services. Some caveats before we get into it. Any of the data that we'll be showing today will be strictly mock or dummy data, so there won't be any true production data shown. Additionally, for this use case, we'll focus on the AWS services, so I won't be naming any specific third-party tool names. However, for this use case, we'll be looking at tools that support key remote work or hybrid work activities, such as video conferencing, file sharing, and messaging for collaboration. Before we get into the dashboards, I wanted to quickly touch on the different type of metrics that we focused on for this use case. First, we have usage metrics. These help us understand who's using a tool, how they're using it, and how frequently they're using it. Next, we have operational metrics, which help us understand how well a tool or application is performing, and give us insights such as CPU, memory, and load times. Moving on, we have customer experience metrics, which help us answer the question of how effectively is a tool or service in supporting a given use case or activity. Additionally, this gives us insight into the true user experience of using a given tool. And lastly, we have application metrics, which help us understand application crashes, outages, and device performance while using these tools. Now, there can certainly be some crossover between these, but we find that this delineation helps us to focus our efforts when we're designing reporting views. With this all in mind, let's jump into our first demo. So by now, I'm sure you're all more than aware that one of the key functionalities of a remote or hybrid workforce is the ability to connect for meetings virtually. We'll start by looking at a dashboard that we built for our video conferencing tool. I wanted to quickly show the Manage Grafana time filter feature. As you'll see, users can easily adjust the time range for a dashboard, and the panels update accordingly, so they can do the analytics that they intend to do. Now, jumping into some dashboard panels. The first few panels that we'll look at are related to the meeting summary data generated from this tool. Meeting summary data gives us a single record per meeting with summary statistics to give us insights into the number of meetings hosted, the video quality trend, the audio quality trend, the proportion of meetings with screen sharing or video on or off, as well as the top meeting hosts by number of meetings hosted. Now, the video quality and the audio quality trend panels give us our first glimpse of the user experience of this tool, so we'll start there. Jumping into the video quality trend panel, I wanted to show off a couple more Managed Grafana features that we find really helpful. The first feature that I'll touch on is the legend feature. With this feature, a user can easily configure summary statistics for each variable in a given dashboard panel. This gives users a quick and easy way to see the distribution of values for a given variable. The next feature that I'll show off is the toggle feature. So not every user of a dashboard finds every variable relevant for the analysis they're intending to do. The toggle feature allows a user to toggle away any variable that they find unmeaningful or unhelpful for what they're intending to do. And the last feature that I'll touch on here is the inspect feature. As you'll see in just a second, the inspect feature allows a user to easily gain access to the data behind a dashboard panel, the query used to pull that data, as well as the JSON model representation if they wish to recreate this panel in another dashboard that already exists. We find that all of these features really help to further self-service analytics and democratization of insights here at FINRA. Now, the next panel that I'll jump into is related to the audio quality trend. This is something that we wanted to recreate for you, as this was an insight that we actually saw and made a change for here at FINRA. Once we jump in, you'll see that there's a significant number of meetings labeled as bad audio quality. After a discussion with the vendor, it was determined that this was due to users being on an older version and not a true user experience impact. After the operations team rolled out a targeted upgrade plan, we're now able to monitor and track the true audio quality going forward for our users. Just a quick example of how we use the data we've collected to change strategy here at FINRA. So that wraps the meeting summary panels. And while these are great insights to have, they're still high level and aggregated at the meeting level, so not quite actionable for individual users. However, in addition to that data set, we also get minute-by-minute data from this tool. This, in conjunction with industry standards, allows us to go beyond usage reporting and get deeper into the real customer experience of using this tool. I'll start with a few panels related to CPU utilization. For this tool, max system CPU is the highest system CPU that a user registers in a given minute while using this tool. We built this panel here to give us a sense of how many users are experiencing high system CPU at least once throughout the day. While this can be a great insight to have, it still lacks a little bit of context around the scale of the impact. So to address that, we built the next panel that we'll look at, which shows the time spent in minutes in high system CPU. In this visualization, we're looking at all the users that experience high system CPU and visualizing the upper bound of the distribution of how many minutes that they spent in that state. The 50th percentile or median value essentially tells us how long the average user who experiences high system CPU is in that state per meeting. A mean value of around 2 minutes tells us that the average user who experiences high system CPU is in that state for about 2 minutes. We've also plotted the 95th percentile value. This shows us the value at which 5% of the data falls beneath, or 5% of the data falls above. So a mean 95th percentile value of around 10 minutes tells us that of the users that experience high system CPU, 5% of them are experiencing it for 10 minutes or more during a meeting. Now that we're able to collect and monitor this data over time, we're able to work with our subject matter expert for this tool to try and improve the user experience over time. So now I'm going to jump out of this dashboard and jump into the second dashboard for this use case, which looks at a messaging collaboration tool. Messaging collaboration tool is something that you're probably all familiar with. It allows users to communicate via messaging, meetings, and file sharing, to name a few. Beyond daily active users for this tool, we're also able to gain insights into chat data, such as the number of chats sent by type of chat, meeting data, such as the number of meetings attended or organized by type of meeting, as well as device usage data, which helps us understand which type of devices users are using this tool on. So you may have noticed that both of the tools we've looked at so far support the activity of attending a meeting. You probably also noticed that the dashboard views are entirely different. It's certainly the case that different vendors provide different levels of data access. And so the question comes, how do we provide an apples-to-apples comparison of tools that support the same activity for our senior leadership teams? To address that, we built the next dashboard that we'll look at, which is our remote work executive summary dashboard. The first two that we looked at were more operational user-focused in that they showed detailed metrics for users that are looking at the tool on a day-to-day basis. This dashboard is more focused for our senior leadership teams and is intended to show high-level tool adoption or usage metrics, as well as a comparison view for tools that support the same activity. This dashboard starts with some key stats around the number of employees at FINRA, as well as a breakdown by business unit. And again, these are all just mock data, so this isn't true production numbers. Moving on, we jump into a comparison view of two tools that support the activity of attending a meeting. In the first row, we have some summary statistics. We also utilize this to signal to our senior leadership teams where we don't quite have data parity between two vendors. Moving on into the usage and adoption metrics, we show some key stats such as the percentage of FINRA that used each tool to attend a meeting daily, the daily active users who attended a meeting in each of these tools, as well as a breakdown of usage by business unit. Just to recap what we've looked at here, we showed two operational dashboards for two tools that support attending a meeting, as well as how we boiled it down to a concise executive summary view. With that, I'll pass it back to Sumalata to discuss our second use case.
Thank you, Logan. Let's move on to our second use case, how we obtained observability for EKS workloads at FINRA. Observability allows us to disseminate the information in one place, and it helps us to troubleshoot triage issues faster. For those who do not know, EKS is AWS Elastic Container Kubernetes Service, which runs containerized applications on AWS EC2's cloud compute instances at scale. I'm sure you guys remember at the beginning where I said big data ecosystem. Bulk of our processing at FINRA runs using EMR's Elastic MapReduce, which is a big data workload engine. However, we have a smaller footprint of COTS applications that we run on EKS. When we were adopting EKS at the beginning at FINRA, observability of these workload metrics was one of the challenge. Having not only observability, just the overall cluster, but looking at the task level, node level, driver level, and in-depth memory details and so forth. Look at whether my task is running long, or whether there is a stuck task, or whether a task is halted, or is there a data skew, or is my task performing unexpected? Is all those kind of data conditions, observability was one of the challenge. As we couldn't collect the metrics, alerting was not easy. And when there are no alerts, it's always reactive rather than being proactive. Workload management was a challenge where profiling was not easy to do it. Is my cluster configuration optimized to the right size, to the right memory settings? the profiling was a challenge. Performance tuning was another challenge where is my workload tuned performant, meaning is my memory setting set correctly, or is my driver executor node level settings configurations are correct? When the QA team comes and does the annual load testing, 1x, 2x, px with market load volatility data conditions, the performance tuning to detect the bottlenecks of data skew or any other performance conditions was a challenge. What does this all mean? It all means that when the workloads go into production, it loads a lot of manual intervention to operations team, where they have to manually monitor them, manually take action, manually resize the clusters, increase the different, or run the clusters on different instance configurations and so forth, and complete the processing. All this will cause SLA impacts and makes customer unhappy. We all went over how we want to make customer happy and measure customer experience metrics in the first use case. All this also adds cost because we are not monitoring properly, so the clusters may be running long and we are not taking action, or the clusters are not optimously set, so it could add all the cost implications. EMR has something called like Ganglia, where Ganglia can give OS level metrics, CPU, memory, disk, and also job level metrics like whatever the job runs, JVM, Spark, Hadoop, Scala. And it also has nice Spark web UI where you can see the visualization of dashboards. So in order to mimic Ganglia like on EMR, we have looked at the options to build our solution. And we tried several in-house options, but from a cost, resiliency, and maintenance perspective, we have chose Amazon Managed Prometheus and Managed Grafana. Amazon Managed Prometheus is a real-time high data collection where AWS takes care of its ingestion, storage, and querying, and also takes care of in the backend. We use, after the data collection, we feed that data to Managed Grafana. Again, Managed Grafana is the nice dashboarding tool that we use. The one difference is here, we used for operational metrics, whereas the first one was for the customer experience metrics. Let's look at the technical architecture again for our solution. As the workload grows or shrinks, as the worker nodes spun up, based on the market data conditions or the configurations that we set up. We have an automation that we built, in-house orchestration, where it looks at certain tags of these nodes and installs the Prometheus agent server. It collects the metrics, what we define in our configuration. We don't want to collect a whole lot of metrics. EKS has a ton of metrics, but we collect what we intend to, and then those metrics are fed to Prometheus workspace. Prometheus workspace is an isolated, dedicated workspace, which has the ability to pull the data only from Prometheus server and push that to Managed Grafana. Managed Grafana, we create a workspace and try to build the dashboards on that. I don't want to repeat SAML integration part in the interest of time. We'll move on to the templatized dashboards. Here, this is slightly different templatized dashboards feature than what I mentioned in the use case one, where here we templatized for task level, node level, driver level, or executor level. So application teams can adopt only that template and can have only those metrics created, because every application is different and they would want only those certain type of metrics. And it has granular control access where administrators, viewers, and operations staff have different type of access. Quick summary, we collected all the EKS operational metrics using Amazon Managed Prometheus and then fed the data to Managed Grafana, where we created the dashboards for overall cluster health. Task, it shows OS level metrics, task level, node level, you name it. And also we have job level metrics, whatever job workload runs, Spark, Hadoop, or Scala, and then application performance metrics. So all these dashboards helped us to identify the problem faster, remediate faster, and which overall helped us to have a better operational posture for EKS workloads at FINRA. With that, passing on to Logan to do the second demo.
Thanks again, Simulata. For our second demo that I'll be getting into, I'll be sharing 2 dashboards that we built and templatized for application teams to take advantage of to gain observability into their EKS workloads. As Sumalata mentioned, in addition to application performance monitoring metrics, with the solution that we've built using managed Grafana and managed Prometheus, we're able to also attain Spark and JVM metrics, driver, task, and node level metrics, as well as OS level metrics. In the dashboards I'll be sharing, we'll touch on a few of these. And additionally, I'll be sharing the templatized dashboard feature just to show you how quick and easy it is to templatize the dashboard. Without further ado, let's jump into our second demo. So I'll start by sharing the templatized dashboard feature. As you'll see, when a user navigates to the settings of a dashboard, they can easily see the JSON model representation of that dashboard. This allows users to copy the entire dashboard, including titles, settings, you name it, and recreate it either pointing toward a new data source or in a new environment. As Sumalata mentioned, we deploy to multiple environments here at FINRA, so having the ability to automate this and not have to manually recreate dashboards in different environments is a huge time saver for teams. With that said, let's jump into the dashboard here. This first dashboard is focused on cluster level metrics as well as OS level metrics. You'll see we have a wide array of metrics such as network traffic, CPU busy, RAM used, etc. The purpose of this dashboard is to allow application teams the ability to get observability into their overall cluster health performance, as well as the configuration of their cluster. The purpose of this is so that application teams have a way to understand where there may be an issue, whereas previously before, it was a very manual and tedious process of digging through logs and a little bit of luck to try and find issues with their workloads. Again, users use this for the cluster level metrics. Now the next dashboard that we'll look at is another template that we built related to pod level metrics. And for those of you that are not aware, pods for EKS are essentially jobs or tasks running on an EKS cluster. We built this so that users can have insight into the performance of their pods, as well as the configuration of their pods, similar to the last dashboard. We start with a few panels related to OS level metrics such as CPU, space, and memory. Then we get into a few pod status level panels, such as the number of pods that restarted, which pods they were, as well as a count of pods by status over time. The remaining panels on this dashboard are related to pod level performance metrics. An example of how a user could use this may be to look at the CPU idle average panel. Say there's a pod that's running and hovering at close to 100% CPU idle on average. That means that almost none of the CPU that's been allocated is being consumed. Perhaps we can reconfigure to allocate less CPU, resulting in cost savings. Alternatively, perhaps there's a job that's running and it's close to 0% CPU idle average, meaning it's consuming all of the CPU or close to it that it's been allocated. Perhaps we can reconfigure to allocate additional CPU to avoid crashes or failures going forward. To recap, these are 2 templatized dashboards that we built for our application teams so that they can quickly and easily gain observability into their workloads without having to manually create dashboards. So now that we've discussed all this infrastructure that we've put in place, we wanted to quickly touch on a few of the future possibilities that we'd like to tackle. First, we have hybrid work analysis. As we've transitioned from fully remote to a more hybrid work posture, we want to use the data that we're collecting to assess that transition and see if we can optimize it for users. Next, we have cloud service portfolio trends. We already assess, but we want to continue and enhance the assessment of the services that we already employ here at FINRA. Additionally, we want to monitor and evaluate how long it takes to onboard new services and see if we can optimize that going forward. For application reliability KPIs, this entails defining a site reliability engineering practice to empower our application teams with tech-level metrics that give them insights into the customer experience of their custom-built applications. Moving on, we have user engagement and collaboration metrics. We want to take all the data that we're collecting to get a sense of how effectively all of our users and employees are collaborating with each other. Are there teams that are more siloed than others? Does this change over time? With the data we're collecting, we should be able to report on that. Next, we have data-driven tool and services investment strategy. For all the tools that we're investing in, we want to use the data we're collecting to determine if these tools are effective for the use case that they're intended to support. Additionally, we want to understand whether or not supplemental tools are needed to improve the user experience of these tools and services. And lastly, optimizing software build and deployment efficiencies. We want to take all the CI/CD pipeline data that we generate to try and optimize and make more efficient the software deployment process here at FINRA. Now, I'm sure you all have great sessions to get to, so before you head out, we wanted to leave you with a few key takeaways from today's session. First, data democratization, which we've been alluding to throughout the presentation. In the first demo, we showed how we democratize insights and data related to tools that support remote work activities. In the second use case, we discussed how we democratized via templatized dashboards observability into EKS workloads for application teams. This takes us into our data-driven decisions. The whole purpose of these projects is to use data that we're collecting and can collect to take the guesswork out of decision-making for our senior leadership teams. Next, a quick note about the serverless nature of these projects. All the infrastructure we've shown is completely serverless, which has allowed us to avoid spending time managing and spinning up infrastructure and focus more on delivering insights. Moving on, we have customer experience metrics. And again, I just wanted to touch on the fact that with Managed Grafana, it's not just reporting on tech metrics, but it can also handle reporting on customer experience metrics and a wide array of different data types. Next, again, I want to touch on the templatized dashboard feature. We showed 2 use cases of how the templatized dashboards really help to speed things up for us here at FINRA, including deploying to different environments and easily deploying to new data sources for different application teams. And lastly, I would be remiss if I didn't mention the data transparency that we've achieved with the data lake that we've built. Our operational data lake has allowed us to pull data in from all across the organization, put it in one place, and deliver insights with that. Along with additional Amazon services, including Managed Grafana, we're able to democratize both insights and data from the data lake, furthering our mission to be a data-driven organization. And with that, I'll pass it back to Helen to wrap things up.
Thank you, Logan. We've made it to the end. Again, I really want to thank Logan and Sumalata from FINRA to join us today to talk about how they leverage AWS services to build out their observability and data democracy practices. Now, if you guys want to have some if you guys want to take away some things, we have 2 QR codes up here. The first one is an observability workshop. If you scan that, it'll take you to a link where we'll walk you through step-by-step how to set up observability on your platforms. The second QR code on the bottom there is actually a GitHub project that you can download. What it will do is it will automatically go into, you can put it into your EKS environment. It will collect the metrics, set it up in Prometheus, and it comes with some pre-built dashboards in Grafana just to make getting started a little bit easier. And with that, oh, you know what? Let me go back. I see some people with their phones out. With that, that's really the end of today's session. Please take the surveys. We'd love to hear from you guys. Sumalata, Logan, and myself will be here. If you guys have any questions, feel free to come up. We'd love to chat. I also have some takeaways. So if anybody takes their survey, wants to come up and show me, I'm happy to pass out some giveaways as well. Thank you, everybody. Enjoy the rest of your re:Invent day.